So here is the question: are armadillos and sloths members of the same animal family at first glance? The idea seems almost absurd. These two creatures look nothing alike. An armadillo, whose name comes from the Spanish word meaning little armored one, is built like a tiny tank. It wears a protective shell of bony plates, has short, strong legs, and carries long, sharp claws designed for digging through soil. Most armadillo species spend their time on the ground rooting around for insects and grubs. Then we have the sloth in Italian and Portuguese. This animal is called Bradypus, a name that captures its famously slow and deliberate movements, unlike the armored and earthbound armadillo. The sloth is a creature of the canopy. It has long limbs, a soft fur coat that often hosts algae and moths, and spends nearly its entire life hanging upside down from tree branches. One animal is a digger clad in natural armor. The other is a slow-moving acrobat draped in shaggy fur. They could not look more different. Yet, appearances in nature can be deceiving. Scientists have long suspected that these two seemingly unrelated animals share an ancient connection, a common ancestor that lived millions of years ago. The real question is not whether they are related at all, but rather how closely that relationship extends. Specifically, do armadillos and sloths belong to the same taxonomic family, or does their connection lie deeper in the past, at some more distant branch of the mammalian family tree? To answer this, we need to look at how scientists classify living things and trace the evolutionary history of some of the strangest mammals in the Americas. The Linnaean taxonomic system gives scientists a structured way to talk about relationships between living things, named after the Swedish biologist Genus Linnaeus. This system arranges life into 7 major levels. At the top sits kingdom. The broadest category, then comes phylum, followed by class, then order, then family, then genus, and finally species. At the most specific level, each step down the ladder represents a tighter grouping with fewer and fewer organisms qualifying for membership. To see how this works in practice, consider humans and the 9-banded armadillo. Both belong to the kingdom Animalia and the phylum Chordata. They even share the same class Mammalia. But at the order level they split apart. Humans fall under Primata, while armadillos belong to Cingulata. Their families are different too. Humans are in Hominidae, and armadillos are in Dasypodidae. This separation at the order level tells us that humans and armadillos are related, but only distantly. They share a common ancestor somewhere far back in time, but they went their separate evolutionary ways long ago. The word family often gets used casually in everyday conversation, but in taxonomy, it has a precise meaning. When scientists say 2 organisms belong to the same family, they are making a specific claim about relatedness. Organisms that share a family are more closely connected than organisms that share only an order or a superorder. The smaller the taxonomic level 2 creatures have in common, the more recently they diverged from a shared ancestor. The connection between armadillos and sloths lies in something called Xenarthra. This is the superorder that unites them along with anteaters into a single evolutionary group. Now, the term superorder might sound a bit technical, but think of it as a broader category than an order. In fact, Xenarthra used to be classified as an order itself, but scientists have since elevated it to superorder status. This reflects our growing understanding of just how ancient and distinct these animals really are. The name Xenarthra comes from Greek, and it refers to a very specific anatomical feature. Xenos means strange or foreign, and arthros means joint, so Xenarthra literally translates to strange joints. What makes these joints Strange is a small bony bump called a xenarthrail found on the vertebrae of every member. Of this group, armadillos have it, sloths have it, anteaters have it. It is a shared characteristic that links them all back to a common ancestor. These mammals are native to the Americas, and their evolutionary story stretches back tens of millions of years. They represent one of the oldest branches of placental mammals on Earth, while armadillos and sloths may look completely different from each other. Today, one armored and low to the ground, the other slow-moving and adapted to life in trees, they share this deep genetic heritage. So here is the answer: armadillos and sloths are related, but not at the family level. They belong to different families within different orders. Armadillos are in the order Cingulata, while sloths are in the order Pilosa, but both orders fall under the same superorder, Xenarthra. They are distant cousins separated by millions of years of evolution, yet still connected by that ancient lineage and those strange joints in their spines. So if armadillos and sloths both belong to Xenarthra, why are we even asking if they are the same animal family? The answer lies one step down the classification ladder. Armadillos belong to their own order called Cingulata. Sloths belong to a completely different order. They are cousins, not siblings. The order Cingulata contains armadillos, and only armadillos. The name itself gives us a clue about what makes these animals so distinctive. Cingulata comes from the Latin word for girdle or belt, referring to the banded armor that wraps around their bodies. This leathery shell is the defining feature of every armadillo species. It is made of hardened skin plates arranged in bands across the back, creating a flexible protective covering that no other mammal possesses. Then, there are those claws. Armadillos have long, sharp claws that are built for one primary purpose: digging. They excavate burrows, root around in soil for insects, and tear into termite mounds with remarkable efficiency. These are not delicate tools. They are heavy-duty excavation equipment, attached to a compact, sturdy body. Perhaps the most famous armadillo behavior belongs to just one genus, the Taxonomic armadillos, which include the three-banded armadillos of South America. Can roll themselves into a perfect defensive ball when threatened. They tuck their head and tail together and pull their armored plates tight until nothing soft is exposed. No other armadillo can do this. Most armadillos simply flee or dig rapidly to escape danger. There is one more detail worth clearing up. For a long time this order was called edentata, which translates to without teeth. The name made sense at the time, or so scientists thought, but it turned out to be inaccurate. Most armadillos do have teeth, they just lack enamel and look different from typical mammal teeth. The old name has fallen out of favor, replaced by the more accurate Cingulata. When we zoom in on the armadillo family tree, things get really interesting. Current classification divides these armored mammals into two distinct families. The first is Dasypodidae, which contains just one living genus called Dasypus. This genus includes familiar faces like the nine-banded armadillo and the Mexican long-nosed armadillo. The second family is Chlamyphoridae, and this is where things get crowded. Every other living armadillo species belongs here, along with some impressive extinct relatives. Speaking of extinct relatives, the Glyptodonts fall into this second family, too. These were massive tank-like creatures that roamed the Americas until about 12,000 years ago. Some stood nearly 5 feet tall and weighed up to 2 tons. Genetic research has shown they were true armadillos, more closely related to the Chlamyphoridae family than to the long-nosed armadillos in Dasypodidae. The diversity within these two families is staggering. Consider the size range alone. At one end, you have the pink fairy armadillo, which measures just 13 to 15 centimeters long, that is about the size of a human hand. At the other extreme, the giant armadillo stretches up to 150 centimeters and can weigh 54 kilograms. That is roughly the size of a large dog. 21 species currently exist across these families, though that number keeps shifting as scientists learn more. In fact, even as recently as 2024, researchers made a surprising discovery. What we have long called the nine-banded armadillo turns out to be not one species but four distinct ones. One of these newly recognized species is the Guianan long-nosed armadillo. This finding reminds us that classification is never really finished. As genetic tools improve, we continue to uncover hidden diversity within groups we thought we understood. So here is the verdict: armadillos and sloths are not members of the same family. They are distant cousins, not siblings. The answer requires us to look at exactly where their paths diverge on the tree of life. Both animals belong to the superorder Xenarthra. This is their shared heritage, an ancient connection that dates back tens of millions of years. But once we move down one level to the order, everything changes. Armadillos belong to the order Cingulata, while sloths belong to the order Pilosa. This separation happened a very long time ago, and since then, each lineage has been evolving on its own distinct trajectory. To put this in perspective, think about humans and armadillos. We are both mammals, so we share the same class, but nobody would ever suggest that humans and armadillos belong to the same family. The relationship ends at that broad level of classification. The same logic applies to armadillos and sloths. They share a superorder, but beyond that they are on different branches entirely. This highlights something important about how biologists use language. The word family has a very specific meaning in science. It is not a vague term for any group of related organisms in the Linnaean system. Family is a precise rank that sits between order and genus. When we say two animals are in different families, we are saying they have been evolving separately for a very long time. Armadillos and sloths, despite their ancient connection through Xenarthra, have evolved into dramatically different creatures. One developed armored plating and became a ground-dwelling digger. The other adapted to life in the trees, evolving specialized limbs for hanging from branches. They are related, yes, but only in the way that distant cousins are related. Their paths diverged long ago, and they have been growing apart ever since.